So the first unit we're going to look at, we're going to start by identifying different classes of numbers. Okay, there's lots of numbers out there in the world, and a lot of them have very special names, or at least sets of them have very special names. So we'll start by defining a set. Okay, so a set is a collection of objects known as elements. Okay, and we use the squiggly little brackets that look like such, encloses the list of elements. So anytime you see squiggly brackets like this, that means that all of the numbers inside are individual numbers within that set, or individual elements within that set. A little different than like a regular set of parentheses, which sometimes could mean a coordinate point or could be a range of numbers. Inside here it's going to be the specific ones listed. Okay, so for instance, we have several different types of sets. One of the most common ones are listed up here, starting with natural numbers. Okay, so natural numbers, an example of those would be 1, 2, 3. Okay, and it would continue on from there. So that's that dot, dot, dot. Okay, when you see that dot, 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 that means we're going to continue on with that same pattern. So natural numbers are things that you find naturally. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Your counting numbers is how I always reference them. Okay, your natural numbers are your counting numbers. Now, whole numbers are going to be the same sort of thing, only they're going to include a 0. Okay, so you still have 1, 2, 3, 4, and all of those. Okay, so dot, dot, dot. Only now we're going to include with that set the 0. Okay, that's the whole numbers. They're separate sets because once upon a time people didn't believe in 0. They didn't think that it made sense to have a number that represented nothing. So early on, way back, they didn't have the number 0. And so they just had natural numbers. They thought you could only count by whole things, like 1, 2, 3, 4, 5, 6, 7, 8. Later on, they decided that it was a good idea to have a 0 in the set to represent nothing and to tell the difference between 1, 10, 100, 1,000. Okay, without zeros, you can't tell the difference between those. They all just say 1. Okay, so we included the whole numbers, and we have the 0. I always like to think of the whole. You got like a hole. That's this is my hole. Okay, so like a hole in the ground. That's the 0. That's my whole numbers. Now, integers. You've heard that name probably a ton, and maybe didn't understand completely what they meant, other than that they're numbers. But the integers are actually very similar to these two. Only now we have to throw in negative numbers. Okay, so it's not just 0, 1, 2, and 3. We're going to include negative, actually let's dot, 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 because this thing would be infinite to the left-hand side too. So dot, 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 and then -2, -1, 0, +1, +2. Okay, dot, 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 out forever that direction. So it's not just negative numbers. It's got your negative pretty numbers, okay, your counting numbers. Negative pretty numbers meaning there's no decimals or fractions yet. Okay, these are just pretty numbers. -3, -2, -1. Okay, and these dot, dot, dot in the front means that I could start at -1,000, -999, -998. Those are all part of the integer set. Okay, pretty counting numbers, only now we've got the negatives and 0 and the 1, 2, 3. And that's going to be considered a subset, which I will talk to you about in a little bit. But that'll be a subset. So now we also have rational numbers. Okay, rational numbers are where we're going to get those fractions in there. So the set of all numbers, A over B. Okay, so you get that fraction look, such that A and B are both integers, and B is not equal to 0, because remember, biggest math no-no ever, you're not allowed to divide by 0. Okay, I can't divide something into nothing. That doesn't work. But, so it says here that A and B have to be integers, so that means I can have negative numbers on top, I can have positive numbers on top or bottom, and those are considered rational. So we've got some integer divided by some other integer. So examples of those We're not going to write out the whole set because we could be here all day, but just some examples. 1/4 would be an integer. -3/2 would be, a rational number, sorry. Okay, rational over rational. 0.25, you got to remember that I can write decimals to be fractions, okay, because 0.25 I can rewrite as 1/4, so that makes it a rational number. 2 would work, 0 would work, negative would work. You got to remember that any whole number, I can always throw that over 1 and call that a fraction, okay, and that's true of every single whole number. I can always throw it over 1 and call it a fraction, so that makes those things rational. When you talk about decimals, okay, and you need to make a little note for yourself here, okay, these are going to be decimals that end or show a pattern. Okay, if you just have some random numbers that never end, like pi, then those are not considered rational, because you can't write those as fractions, okay, because they're never-ending decimals. And that's where the irrational numbers comes in, okay, it's the set of numbers that cannot be expressed as a quotient. Remember, quotient means divide, okay, so it cannot be expressed as a quotient of integers. Basically, it can't be written as a fraction. Okay, so if you can't write it out like a fraction, then they're going to be considered to be irrational. These should be really easy to identify. Again, stuff like pi. Pi is a never-ending repeating decimal, okay? Never repeating decimal. It's 3.14 blah, 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 and it changes and does all kinds of stuff. Square root of 2 is going to be the same thing, okay? Anything that has pi in it, so -5 pi, -12 pi, +15 pi, 7,000 pi. If it's got pi with it, it's going to be irrational. Anything that doesn't have a perfect square, so square root of 2 is irrational, square root of 3 is irrational, square root of 5 irrational, square root of 7 irrational. Okay, so there's a lot of irrationals with the square roots. You just have to make sure that that square root doesn't have a perfect square. So for instance, the square root of 4 is 2, okay? So that would not be irrational. Alright, so this next little thing kind of demonstrates what a subset is, okay? So right here, and this set of notes doesn't actually have it, but I'll add it right here for you. So a subset is a part of a set. Okay, a subset, okay, subset, which this right here means that it includes. Okay, that's what subset actually means. So when you hear subset, okay, that means that it includes the other piece, and we write it with this notation. Okay, it's like a little C kind of looking thing. It's a little wider than a C with a line under it. That's considered a subset. So for instance, okay, if I look at those natural numbers, okay, natural numbers were the 1, 2, 3, 4, 5, okay, well, natural numbers here are also whole numbers, right? Because if you look back up here, okay, the natural numbers are all in the whole numbers plus the 0. Okay, so the natural numbers would be a subset. So natural numbers is a subset. That's what that means. Oh, sorry, you can't see it. Okay, natural numbers are a subset. Okay, you draw your C with a line. Okay, of the whole numbers. Okay, because again, the natural numbers is part of my whole number set. If I look at my whole number set, I got natural numbers plus 0. So that would make natural numbers a subset of whole numbers. Okay, for the exact same reason, okay, whole numbers would be subsets of, and really it would be, if you're looking at this picture, the whole number would be subset of integers or rationals or real numbers, which we haven't discussed just yet because I skipped that one on accident. Okay, the real numbers is a set of all numbers that correspond to the number line. Okay, so real numbers, notice it goes all the way across, including irrational. So every single number you can think of would fit into that real numbers category. Okay, every number you can think of fits into real numbers. The only exception, okay, the only exception to that are complex numbers or imaginary numbers. Everything else counts. Okay, so if they ask you to list the real numbers, you're going to list every number except for anything with an I or an imaginary number. So, going back to this, so when we talk about that whole number, again, it's a subset of any of these things above it. The only thing it's not a subset of is the irrational numbers, because that's a whole different set. Okay, there are no whole numbers in irrational numbers. So, whole numbers would be a subset of integers. Okay, or I could say whole numbers is a subset of real numbers. Okay, because within real numbers you would find your set of whole numbers. Okay, so hopefully that kind of clears up what they are. An example of a non-example, I guess, would be if you looked at like rational numbers. Rational numbers are not a subset of natural. Okay, because if I look at my rational numbers, or if I look at my natural numbers, I'm not going to find my entire set of rationals. Okay, the other way is true. If I look at rational numbers, I will find my entire set of naturals. Okay, but if I look at naturals, I will not find my entire set of rationals. So, that's kind of how that works. I'm going to go ahead and complete this because we started with natural numbers inside here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And when you get the whole numbers, you get 0 plus those numbers. Okay, when you get to integers, you get to negative numbers. Okay, you're going to get all those negative numbers plus the 0 plus the 1, 2, 3, 4, 5. When you hit those rational numbers, now we're going to get decimals and fractions. Okay, that thing's got a repeating pattern, so that would be rational. That's written as a fraction, that's rational. They can be negative fractions, that's fine, that's rational. Okay, so any of those would be rationals. Okay, so rational numbers includes all these fractions plus my integers, which also includes whole numbers, which also includes natural numbers. So hopefully you can kind of see how those subsets work. Okay, any one of these three inner ones would be a subset of rationals. Alright, so now irrational is going to be all of those other ones. So pi, 3 pi, negative square root of 2, positive square root of 7. Those are going to all be your irrational numbers. And then real numbers, okay, we don't include anything else. Real numbers, everything's been accounted for as of now, and real numbers just constitute the entire set here. Okay, so everything that fits into this is also a real number. If it's irrational, it's real. If it's rational, it's real. Integers are real. Whole numbers are real. Natural numbers are real. So these are all subsets of real numbers. Okay, so that's what a subset is. That's what your different categories are. You do have to be able to identify those on the test by looking at sets of numbers. So, for an example of that, given the set, negative 7, negative 2/3, 0, 0.25, square root of 3, 4, and 17 halves. So here's a set of numbers. Okay, they want to know, list the numbers with the sets they belong to. So within this set, okay, how many of those are actually natural numbers? Okay, so natural numbers are just my pretty counting numbers. Okay, nothing fancy, no negatives. So look at all of your just your pretty numbers. Negative, negative, 0 doesn't count in naturals. That's a decimal. That's irrational. So 4 would fit into the natural numbers. That's another fraction. So 4 is the only one. So this is my set of natural numbers out of that set of numbers. Okay, so now look at whole numbers. Okay, well, whole numbers, I know without a doubt 4 is, right? Because 4 whole numbers includes all my natural numbers. Okay, that's natural is a subset of whole numbers. So 4 is going to be part of my whole numbers, but what else? Well, when I get the whole numbers, I have to include the 0. So I do have a 0 right there. So 0 counts as a whole number also. Okay, so I've got 0 and 4 are whole numbers. So now let's look at integers. Integers, we've got positive numbers, negative numbers, and 0. Still all pretty numbers, no decimals, no fractions. So let's look at those. I've got negative 7, That's an integer. Okay, fraction doesn't work. 0 works. Decimals don't work. Radicals don't work. Whole positive numbers work. And there's another fraction, so that doesn't work either. Okay, so now we've got our integers. Now let's look at rational numbers. Just as soon as this thing pops back up. Okay, so now rational numbers. Okay, now we can bring in all of our fractions and stuff like that. So rational numbers. Okay, well, -7 it's still a rational number. Remember, I can toss that over 1, and that makes it a fraction. So rational numbers are fractions. So -7 would work. Okay, -2/3 is definitely a fraction. 0 I can put over 1 is still a fraction. Okay, 0.25, that's 1/4. I can put that as a fraction. Square root of 3. If you put the square root of 3 in your calculator, you're going to get some long decimal. Now, the calculator will stop at eventually, but only because your calculator can only print out so many decimals. So, square root of 3 is not going to be rational. 4 is rational. Okay, and 17/2 is rational. So I've got all my fractions, I got all my negative pretty numbers, I've got all my positive pretty numbers, I got my 0. Okay, see how it's just building every time. We started with 4. That's my natural numbers is my smallest set. Whole numbers, we included the 0. Integers, we included the negative. Okay, but I'm adding to my list each time. Rationals, I've added in my fractions. Now, irrational is the one where we're not going to add in. Irrationals is different. These are only the ones that cannot be written as fractions, and we just said all of those could. So the only one that can't be written as a fraction is going to be that square root of 3. Okay, the square root of 3 cannot be written as a fraction. Again, it's a non-repeating decimal that just kind of goes on forever. So it's going to be irrational. And then real numbers. Real numbers is the easiest set. You should never get real numbers wrong because it's going to be the entire set. Every single number in here is a real number. I have no imaginary numbers in there. So every number in that set is also a real number. So 0.25, square root of 3, 4, and 17/2. Okay, so now here comes the portion of the class where you get to try things on your own. Okay, it's one thing to sit and listen to me talk about it. It's a whole other thing to think through and process. You really need to get good at thinking through and processing these things, because part of the hardest part of math is not necessarily being able to replicate what I do, but knowing what to do and when to do it. Okay, and that's where you have to learn to process. So, if you're doing this by video, you want to hit that pause button. Okay, try this. Try to do this on your own. See if you can put these numbers in the correct categories. And once you do that, hit that play button again, and then you will get to check your answer with mine, because I'm about to do the problem here. So please hit that pause button, give it a shot, then come back and see if your answer matches mine. Okay? So hopefully you've just come back from hitting pause and trying this all by yourself, and we will do it together. So out of those numbers, the only ones that are nice, pretty positive numbers are 1 and 6. Okay, on the whole numbers, I do have a 0 in there, so that's going to be 0 plus my pretty positive numbers, 1 and 6. Integers, now we're going to include our negatives. Okay, but -2 is going to go not fractions or decimals yet, so just the -2, 0, 1, and 6. Okay, all those pretty numbers plus that new -1. Okay, rational numbers. Now here comes all my decimals. -2, -0.75, because that's a just nice ending decimal. Okay, nice ending decimal. So 0.56, of course, is already a fraction. 1, pi is not. We have to leave pi off because that is a non-repeating decimal. Irrational, the only one up there that is irrational is going to be pi. So pi is my set. That's the whole set, just pi. And then real numbers should have been the easiest one up there. No thinking, really. You just write down the entire set. 0.75, 0, 5, 6, 1, pi, and 6. Okay? So that is going to be how you identify sets of numbers. Okay? That's how you categorize them into their own little sets. Now, one more part of this. Okay, so order property. When you talk about the order property for real numbers, okay, you're talking about your less than, your greater than, those kind of things. Okay, this should be really, really easy. The biggest thing is just remembering what your inequality symbols look like. Remember, these are inequalities. Going back to the day, you know, maybe you've seen this, maybe you haven't. Okay, the smaller one is inside the belly. Okay, the smaller one's already been eaten, so the A is less than, the B is greater than. I don't know, some people have seen alligators and all kinds of fun stuff, but whichever, it's always pointing at the smallest one. So here, if I'm looking at something like this, okay, I've got A and B. Okay, the less than symbol. So here A is less than B, which if you're talking about a number line, that's easy to see, because remember, everything increases as you move to the right. So this is my less than symbol. Okay, when you throw a line underneath it, that means less than or equal. Okay, so less than or equal to. So it's either less than or equal. So for instance, if my number is 5, that means my number would be less than or equal to 5, means that it could be 5 or 4 or 3 or 2 or 1. Okay, that's literally what it means. It's some number smaller than or equal to 5 for my example. Alright, so then here, okay, we have greater than. Okay, these are going to be greater than symbols. Okay, so if you're looking at here, B is less than A, so B comes before A on the number line. Okay, this is my greater than symbol, so if it flips over there, that means greater than, because again, the big part is opening towards the big number, small part towards the small number. Okay, any way you can think of it that'll help you remember it, that is fantastic. Some people use the fish, some people use alligators, some people just use small point, small number, big number. Whatever works for you, but you do need to know it. We will do a lot of inequalities in this class. Okay, so greater than or equal to, same sort of thing. Anytime you see that line underneath, it means equal to. Obviously, an equal sign means equal to. And then when you see an equal sign with a slash through it like that, that means not equal to. And we will use those when we start talking concepts and theories. Okay, you'll talk about things being not equal to things. Okay, so if I wanted to select the sign that would best complete the following, or if I want to order these things, okay, you just have to figure out whether this number is less than or greater than. So -1 less than or greater than 0. Okay, negative is obviously to the left of 0 on the number line, so -11 or -1 is less than 0. Okay, it's better to be at 0 than a dollar in the hole, so -1 is less than. Here, you're going to have to convert sometimes. 14 over 2 is equal to 7. Okay, that thing is 7, so that means 7 equals 14 over 2. Those are the exact same value, just written in a different manner. Okay, this is the one that kind of throws people off a little bit. -5 and -6. Remember, -6 in the whole means you're more negative, right? You're more in the whole. So -5 is actually bigger than -6, but people's mind immediately sees 5 and 6 and they say smaller, but be very careful. Okay, the bigger the negative, the smaller the actual number is. Okay, so -5 is greater than -6. Absolute values. Okay, you got to be able to determine what an absolute value is. You should have a very general concept of it. We'll go a lot deeper into absolute values later on, but you do need to start with a general idea. So the absolute value of a real number A is denoted by, okay, absolute value of A. So that's what those straight lines are. They mean absolute value. And it is the distance between A and 0 on a number line. Okay, so for instance, the absolute value of -3 is just 3, because if you're looking at the distance, so if I go to -3 right here, okay, my distance from 0 to 3, well, I moved 3 units. Okay, I moved 3 units left, but I still moved 3 units. Okay, just like if you leave your front door and you do a mile to the left, well, it's still a mile. Whether it was to the left or to the right, it's still a mile, and that's what we're talking about here. If I come out and I go left, well, that was still 3 units. I just went left. Okay, same thing over here. If I come out and I go right to 3, well, that's still 3 units. Okay, so when you talk about the distance, which is the absolute value, it's 3 units. So it's going to be 3 units here and here. Okay, so the absolute value of -3 is 3, and the absolute value of 3 is also a 3. Okay? Keep in mind that distance is always positive. Okay, there's no such thing as a negative distance. We can have a negative displacement if you've talked about that in science class ever. Okay, but you cannot have a negative distance. So distance is always positive. Okay, so the absolute value of A will always give us a positive answer. That's an important concept to keep in mind. Okay, it will always give us a positive. Sorry, I'm thinking and talking and writing all at the same time. Sometimes that can be a bad thing. Okay, alright. So the distance is always positive, which means that the absolute value of A will always give us a positive answer. Okay, it will always give us positive answer. See, look, I put a S on it, didn't need one. Alright, so these little absolute values, these should be super simple. We'll get much more complicated with them later on, but right now we just want to make sure basic concepts are there. Okay, so for instance, if we did something like this, okay, absolute value of 4, just 4. Absolute value of -5, it's just 5. I'm just getting rid of that negative because the distance from 0 to -5 is still 5 units. Okay, the distance from 0 to 0 is still 0. Okay, I haven't gone anywhere. I'm still sitting at home on my butt watching TV. Okay, 0, the distance from 0 is still 0. Okay, the absolute value of -1/2 is +1/2, and the absolute value of 5.6 is just 5.6. Don't let these things throw you off. They should be super easy. You're just dropping the negative. They'll get complicated later on, but right now that's all we want from you. Okay, so now we're going to put those two skills together, where we're ordering them using absolute values. So the absolute value of 0, is it greater than, less than, equal to 2? Well, okay, absolute value of 0 is 0, which means that it is less than 2. Okay, the absolute value of 5 is 5, which is equal to 5. Sorry about the music. School just let out, and there's music on Fridays. Alright, so absolute value of 3 is +3. Now be careful here. When I have a negative outside, okay, the absolute value doesn't affect it at all. So the absolute value of 2 is still, -2 is still +2. Okay, but that negative that's out front comes down, so it's still -2. 3 is bigger than -2. Okay, you got to be very careful with those negatives that are out front. Okay, the absolute value of -2 is +2, but there's still that negative out front that had to come down. Alright, so the absolute value of 5 is 5. Absolute value of 6 is 6, so 5 is less than 6. And the last one, absolute value of 7 is +7. Absolute value of 6 is +6. 7 is larger than 6. Okay, so that would be my suggestion on how to go about these. I would go ahead and make sure I write down the actual absolute value, just because mentally when we start trying to do this stuff in our head, we tend to make small little mistakes, and those small mistakes add up on tests. So take your time, write it out. When you're doing your homework, you have to write it out, because you have to show me all of your work. Without the work, you get no credit. You'll find that is very, very true in my class. So make sure you're showing work, even if it's just little stuff. Okay, that's the end of your first lesson. Thank you.